Hi everyone, my name is Felipe and I'm here to talk about server-driven UIs, more specifically about dynamic flow, the WISE approach to server-driven UIs. I will share the collective experience of Android, iOS, web, and backend engineers to build such solution, and some challenges and learnings we had along the way. So hope you enjoy, and let's get started. So first, a little bit more about me. I'm a senior Android engineer at WISE. I have been working with server-driven UIs for 4 years. And if you, just like me, remembers how it is to develop Android apps in Eclipse, welcome to the old people's club. And sorry to my Italian friends, but I do like pineapple on pizza. And I would like to start by telling you a story. When my journey with server-driven UIs started. It was a few years back when I used to work developing Android applications for the aviation domain. And there we have the concept of advanced passenger information, which is basically data you need to collect from passengers before they board on a flight, commonly known as the check-in process that every airline does. And as an example, if you have a domestic flight in Brazil, you might need to provide some information. But if this flight is international, let's say from the Brazil to the UK, you might need to provide a different variant of this data, such as your passport number instead of your identity number. And depending on the origin and the destination of your flight, the variations can go on. So one interesting aspect about those examples is that although they have similar structure, the content of the screen is very, very dynamic. It can vary very much. You can imagine the world having more than 200 countries, how many combinations of origin and destinations we could have. And I remember that time was very, very hard to maintain such screens, because every time we needed to change something on a specific route, we had to deploy changes on all platforms. And for the case of mobile, we need to deploy changes on the app stores, wait for reviews, wait for the users to update their apps, then to realize that we had an inconsistency in one of the platforms. So we had to fix and coordinate everything. So it was a bit of a hell. And then I moved on. I joined WISE. And at WISE, we have a different mission. It's money without borders, instantly, conveniently, transparently, and for a fair price. And at WISE, we have 3 main products. The WISE account, which serves more than 13 million customers today. The business account, which serves more than 300,000 businesses. And the WISE platform, where we sell our infrastructure as a service to power many partners across the globe. And can you guess what I found when I joined WISE? More forms, more data collection. And it was a deja vu moment, remembering the nightmares from the past. Like, I don't believe I will need to maintain such screens again. But after reflecting for a while, I come to the conclusion that this kind of scenario is not that uncommon. Like, business around the world, for security or regulatory or even business reasons, they need to collect data. They need to have some sort of like dynamic screens on their products. And to my luck, my colleagues at WISE were working on a solution for that. It was called Dynamic Flow. And Dynamic Flow is a server-driven UI solution. And at the time, I didn't know what was that. So I think it's fair to explain what this is exactly. So a traditional way to develop mobile apps, it's a client-driven approach. So basically, we have a backend. The backend will serve the clients with some sort of raw data, usually in JSON format, containing like data around your business. And the clients will consume this data somehow. The interesting aspect here is that the backend, to generate this data, it needs business logic. And the clients, they also need business logic to interpret the data and generate the experience. So we have business logics all throughout all platforms. and all technologies. In contrast, on a server-driven UI approach, instead of you serving the clients with raw data, you serve them with instructions on how to handle the screen. So you can concentrate all the business logic regarding like your field or your industry or something on the backend and serve the clients only with instructions on how to handle the screen. In other words, this is just another way to make the UI dumb, moving, handling your business logic to the backend. And we have a couple of benefits by doing that. First, I've already said, you are concentrating business logic on the backend, preventing complex code repetition. But at the same time, since all the clients are receiving the same instruction, you are likely to have less inconsistencies there. Another very interesting aspect is that you can have your changes deployed to the backend, and by doing that, you can skip the app store process of deploying changes. So you have faster iterations and also faster experimentations. And finally, a thing that happened at Wise and was very interesting, we had some teams that they didn't have mobile engineers, and they wanted to deploy changes on the front-end client. And they usually relied on some mobile engineer to be free and help them. Now, with a server-driven UI approach, we gave more autonomy to back-end engineers to deploy changes on the product on a certain limitation, of course. But it's at least a bit more autonomy. And this is not a new idea. Server-driven UIs, I think, as far as I remember, people from community started to discuss about this topic in 2018, more or less. And we have seen many companies like implementing their own server-driven UI ideas, such as Monzo, AutoTrader, Airbnb, Spotify, and so on. And it's fair to say that because as mobile development gets more complicated over the years, every engineer will try to find solutions to scale their product. And solutions such as Kotlin multi-platform that we are seeing in the event, Flutter, Reactive Native, and even server-driven UIs are all solutions to centralize business logic, but with different philosophies, different maturities, different trade-offs, and we can even sometimes combine them into a single solution. So after this small introduction, I have what I'm going to talk next. I'm going to dive deep in how we built our server-driven UI approach, hoping that you can get maybe inspired or you can get some information to build your own. And then if you stick with me, I'm going to show a demo, a live demo, so pray for me. And after, some challenges and conclusions. So let's start with how we did Dynamic Flow, our server-driven UI solution. So we believe that for you to have a good and useful server-driven UI system, you need to have 4 ingredients for this recipe. So the first ingredient is a good specification. So what is a specification? We have many clients with different programming languages communicating with each other. So how can we be sure that everyone is speaking the same thing, or we can communicate with all clients in the same way? And we can do that by specifying a solid contract between the backend and the client. So let's see what I mean by that. So let's say this screen, it has 4 components: a hello world label, an image, a text field with first name, and a button. What would be the best way to describe this screen from the backend? The straightforward approach is, okay, I can have a list with 4 components, 4 elements. Each element has a type. Each type map to a component on the screen. Feels easy, right? But in practice, it's not that easy. It's too easy to be true. A real life situation your server-driven UI system will need more than just rendering isolated components. It needs more than that. Maybe you need to take control of the full screen and have a more tailored experience. Maybe you need to navigate from one screen to the other, both server-driven. You might need as well to handle state between one screen or pass a state between one screen or the other. So things can get way more complicated. And in the end, you need to build some sort of flow-like experience where you have like an initial screen and a finishing like result. Well, let me show you how the communication looks like in practice. So you have a client. The client will request a screen from the server. The server will return a response with a specification. And here, the interesting part is that the user will interact with this screen. So for you to take the decision on what to do next, you need to have the data from the screen that the user is interacting. So you perhaps collect the data of like the first name of the user, let's say. You need to send it back to the backend, so the backend can take the decision on what to do. One decision is, I might show another screen if the data that I collected was not enough. But if the data was enough, maybe I can finish the screen. So we have many like alternatives or many branches of things that we can do. So we needed to come up with a criteria for our contract to meet like everything that we needed. So our criteria, we had 3 main points. Was basically, we wanted to have as little state handling as possible on the front end, so the UI could be as dumb as possible. Second criteria was we wanted to optimize for data collection. And the third criteria was we wanted to give the backend engineers as much flexibility and control as possible. And to help us with that is that when we found JSON schema. Have anyone here in the audience heard about JSON schema? Yeah, I see some hands. Yeah, cool. So JSON schema came to our rescue. And JSON schema is a standard for describing the structure of a JSON. So let me tell you an example. So the JSON on the left is the JSON schema, and the JSON on the right is like the JSON I'm describing with the JSON on the left. So if you see on the left, I'm describing a JSON object with 4 properties: name, gender, age, and has account. Each property has a type. So exactly the description that I have on the right. But what we also found is that we could generate values from this description by having a form-like experience generated by the JSON schema on the left. So you could basically have both things, like a form-like experience and the structure of the JSON you collect, described by the same JSON schema. So repeating, with JSON schema, we found a way to describe how to collect the data, but I found a way to describe how to build forms. But still, there was something missing. What if we want to collect or we want to handle something that's not exactly a form input? And that's when the previous the previous specification, the straightforward one, the list of components, came in hand in this situation. Because here I have more components than just form inputs. I have a heading, I have an image. Sometimes they are not even interactable. They are just there for enhancing the experience. So what we did, we took the best of both worlds. So our specification, we have a way to describe how the component should be laid out with this layout array property. And we have a way to describe the structure of our response with this schema array property. So let's see the full example. So first, we have a layout array. This layout array has 4 components, and the 4 components are mapped here on the screen. Secondly, we have our schema array, describing how the data would be collected. And you can see in the pink component, I am referencing my schema array into my layout array. So I can have some sort of form container with my server-driven UI. And with that, I could have control, or I can have control for the UI handling and for the data collection. I can rearrange the components the way I want without affecting the data collection. And well, with that, we have our specification. Let's move to support libraries. Those are the next ingredients of our recipe. So now that we have a common language, how do we know that our clients are doing exactly what they are told? And to achieve maximum consistency, we created 4 libraries for that. First library is a backend library. And at Wise, most of our backend services are built in Java, but we have some built in Kotlin. So we took advantage of the Kotlin interoperability functionality, and we built our backend library in Kotlin. And here, the backend engineers are going to use this library to build their responses, their form, according to our specification. We also have 3 client libraries, each one built in their own native technology, and each client library will know, based on the instructions, how to handle the screen properly. Looking at a high-level architecture, we have our 3 front-end libraries, and each library has a similar architecture as the traditional mobile apps today. So we have an UI layer, a domain layer, and a data layer, each one of them built in their own respective native technology. And we do have our backend libraries, which our backend engineers are using to generate the form. And to coordinate all these communication, we decided to make our documentation and put our specification entities all in the backend library. So every time a client library is implementing a new feature and they want to refer what to do or what the behavior should follow, they should refer to the backend as the single source of truth of our whole system. And in addition, to make it even more interesting, we added some convenience functions to backend engineers so they could build their forms in a more pleasant way. So we added templates of common screens that we have at Wise, builder methods and DSLs to help them. And you can notice that the backend library here was taking a bit of a protagonism in the whole SDUI system. So we took a step further and we made our backend library Kotlin multi-platform. So we wanted to leverage the power of KMP to have an even more interesting system. And what I'm going to show you now is a work in progress. This is our vision for the future of the system, and we are very excited about. So first, we realized that data layer entities on our clients, they were not really platform specific in a sense. So nothing was preventing us from sharing entities from the Kotlin multi-platform libraries to the client libraries. With that, we would make the serialization and deserialization process a bit more easy. We have we want also to take a step further, and having the same logic, we could also replace specific domain logic on our clients with our Kotlin multi-platform logic. And if you follow what I'm going next, I'm going to take our jobs now, just to replace all entities and logic in all layers coming from a single multi-platform library. So we would have our whole SDY system implemented in a single place. So this is what we are excited about. We have seen talks about Compose multi-platform coming on, and yeah, very interesting times. And those are the support libraries. And finally, the last ingredient is a good design system. So we need to answer this. How can you be sure that you have an accessible and consistent UX across every platform? You can imagine your SDUI system as a building blocks, and you need to ask where those blocks are coming from. And they come from a design system. The design system will make sure that if you handle a text field, this text field will have the same behavior across all platforms. If you have a button, the button will have the same layout on all platforms, and the look and feel of your company, of your product, will be consistent. What we did, we took a step to an interesting step of making our client libraries a black box and not coupled to the design system at all. So what we can do, we can plug in a design system to the library by following a specific interface that we created. And we do that by, instead of having like specific components from the design system on this interface, we simply generated more generic components from this interface. So any design system could be plugged in. And here we are focusing more on semantics instead of actual implementation. So this would allow us to, as again, plug a third-party design system on our library, making it a bit more appealing for open sourcing and other people like using it. Right now, the library is not open source. We are still working on that, but we are kind of excited with the possibilities we can have with that in the future. So this is the main gist of it regarding the recipe. And now that you are here with me so far, let's try this demo. I'll show you what we did. So cool. Here, I hope you can see. Let me just, okay, cool. So here on the right, we have a simulator with our Android client library. And here on the left, we have IntelliJ with our backend library. And here I'm running a local host server. And I will build a step live for you. So this is our DSL. We can build a step with it. And you can see that I have an ID, which is used for analytics purposes. And I have a title, droidcon, let's go. And here is my server-driven screen. So first thing I'm going to do is decide what data I need to collect. So I'm going to collect a first name and last name. So I will start by building a schemas array. I would like to collect a JSON object. This JSON object will have a couple of properties. And first name and last name should be strings. So let's collect a couple of strings here. So first name. And I wanted to give this a title so the user can know what to do. First name. And then I can copy that. Last name. Okay. I have my data to collect, but I need to describe how I'm going to lay out this. So that's why I told you before about the layout array. So the layout array, we have a form container. My form container takes a schema ID. So I need to define an ID here. Let's say my ID will be personal info. Yeah. Cool. So I'm going to run my server. Okay, server is up. And here, it's my first name and last name, all backend driven. But this screen is not complete. Like, okay, I can type my first name and my last name, but I don't have a way to proceed or to finish the flow. So I need to add a button. So let's say I'm going to create a button. This button has a title. Continue. And this button will have an action. We need to define where we are going to send the data we collected. So we are likely sending it to another endpoint, so the backend can take the decision on what to do. I have a predefined endpoint here, submission path, and I can even declare how I want this HTTP request to be made. So I can do like a method, post, yeah, cool. This endpoint here is predefined to return another screen with the payload I sent from the first screen. So I'm going to show you what this means. So running the server, cool. Again, here's my button. So I can type my name, Phellipe Silvar, hit continue. And this is my next screen. And I'm showing you the payload that I generated. It's first name Phellipe, last name Silvar, all strings. So let's make things a bit more interesting. So I would like to ask about my age. And for that, I need an integer. So, okay, let's say integer, age, title, age. But we can enhance the experience a bit, and we have a couple of more like features on each component. So I can add a description, and I can add a support text to say something like, lie about your age here. And finally, I can have also a Boolean, which is lying. I can have a title saying, are you lying? Okay, let's see how it looks. Oops, let me check, okay. Cool. Now I have a form represented here with my schema arrays. I can do Phellipe, I can do Silvar, I can do 99, and I say I'm lying. You can see that the response I generated is following the correct types. So my age is not a string, it's a real integer, and this lying is a Boolean. But how about this? I clear my name here, and I click on submit. So I'm submitting empty data. So maybe you can make like some field like required. So you can do that. You can go to your object schema and say like, I have a couple of properties that are required, maybe a first name and a last name. And I also can enhance the experience by coming to my layout array and say, I have an alert. My alert has a markdown content. And I can say, like, full name is mandatory. Cool. Let's run. Okay, now I have an alert here saying my full name is mandatory. If I try to continue, they will block me from continuing. I can type stuff, and I can continue the flow. So yes, this is the gist of like a server-driven UI. You can do way more than that. You can explore like many components in the layout array. You can explore different ways to collect data with the schemas array. And yeah, this is how the experience from backend engineers look like. So now it's time to take a brief. Cool. Moving on. I would like to share some challenges we had while building the tool, and hope with these, in case you are building a server-driven UI, or if you already have a server-driven UI in your company, it can help you maybe to have some ideas. First challenge for us, one of the most difficult ones, was versioning. So today we use semantic versioning in our libraries, meaning that any bump we do on a major version, it would mean that we would be introducing breaking changes to existing integrations. A minor bump means we can add, we are introducing changes that are backwards compatible, like features that are backward compatible. And patch is for minor backward compatible changes. In real life, this is what is going to happen with your SDUI system. So you would have backends using different versions of your SDUI libraries, serving clients using different versions of the library as well. Especially because customers, they don't usually update their apps that frequently. There are still people using very, very old versions of the app. So what we did to kind of organize this mess, we try to have a big focus on backwards compatibility. So it would mean that we could assume that server and client having the same major versions, that wouldn't be that problematic. Of course, some inconsistencies can happen here and there, but it wouldn't be that complicated or problematic. So this helped us move forward. But it leaves us with some other complicated scenarios, such as this one. Like a backend server is way ahead in terms of version, and we are serving very, very old clients. So by having a big focus on backwards compatibilities, even with having a client library far ahead, we still allow people to build components using the old specification. So these allowed us to do some sort of dynamic endpoint versioning. And we do that by every time a client requests a screen from the server, we send an HTTP header with the version on it. Again, the backend will take the decision on what to serve. Here, since my header is saying that my client has a specification version 1, I would serve with a component from version 1. But if my client is on a newer version, I can try to serve with a more modern or more up-to-date component. In some situations, you need to do traditional endpoint versioning and have different endpoints serving different contracts. And with that, we could mitigate a little bit more this versioning mess. But still, we have a even more complicated scenario, which is some backend services are using very, very old version of our library. And sometimes the clients are far ahead, and they are not really compatible with the specification we had before. So this is sometimes blocking for us to release new features. And what we do, we try to educate and push teams to migrate the backend services as soon as possible. So it's more of a coordination and communication effort. And it is still not perfect. We haven't nailed that yet because we realize that breaking changes can come in different and unexpected ways. So let me show examples of things that can happen. On the backend, we have this alert definition where we can put a markdown and a style, let's say positive, negative, as I showed you in the demo before. A type of breaking change, very obvious one, is when you add a new mandatory property. So if you add a new mandatory property, every backend engineer that bumps their version, a major version on their system or on their backend service, they will have probably a compilation error requesting them to add this new property. This is an obvious breaking change. A less obvious one is when you make an property optional. So if you have a style and you make your style optional, on the backend perspective, it's not a breaking change because they already had a mandatory property before. This will not generate a breaking change. But for your client that is expecting a style, and if you send a null, it may not know what it's going to do. even considering that clients are using like different versions of like your specification. So this is a less obvious breaking change that can break your client. And an even less obvious one is, for instance, if you change the default property of a class. Let's say here, my default style is positive, and I change it to negative. This is not going to generate any compilation error or any crash, but this is a visual breaking change, behavioral breaking change. So your integrators, your backend engineers, friends, they are expecting the system to behave in a way, and suddenly it's behaving in another way. So this we need to take care about. Second challenge is knowing that a server-driven UI system is not a silver bullet, and it has a clear purpose. So if someone from your company comes to you and say, let's replace all these screens on your app by server-driven, please don't do that. So we came to our own purpose for SDUI system, which is it's great when you are building forms or flows, when you are using standard UI components, maybe from your design system, when your flow is complex or very dynamic, and you have requirements that change rapidly. But we realize that an SDUI system is not great when you try to make it a general purpose layout system. You want to make every layout with it. If you think it's a replacement for every backend driven frontend, and if you are aiming to cover 100% of screens or designs very granularly, so this is not a good idea. The most iconic example is the Wise home screen. So there were discussions on the team to say, should this screen be using dynamic flow or not? And we decided to not go with it because the experience they needed to have in this screen was very, very granular, very tailored. And we didn't want our system to be a bottleneck for the team to build the experience they want. So we decided to not go with that. But many, many other screens in the Wise app are server-driven with dynamic flow. And in fact, we have more than 500 unique screens being generated today. So just because some screens are not fit for the purpose doesn't mean your system is useless. So there will be scenarios where they are going to be useful. So have that in mind. Last challenge is how can you be scalable and flexible at the same time? So we had a situation where a team wanted to do an experiment, and they had a server-driven flow already built. And the A/B test consisted in using a component that was not on the design system. So, and after all, it was an experimentation. So they wanted to experiment with something like crazy or creative. And we didn't want our system to be a limiting factor for them to experiment. So we had to find ways for teams to inject their own custom components outside the design system. This was very challenging. But we did that by having an interface. Here is an example of an interface where we implement a handler for a text input. So we have this composable handler function where we use our design system text input, and it needs to conform with some rules that we created. And what we did, as long as you implement the same interface, you would be able to inject your own custom text input in a way. And with that, you could have delightful experiences such as this one. So there is an internal joke in the team that says, just because you can put pineapple on pizza doesn't mean you should put pineapple on pizza. So it needed to be used with responsibility, and we try to educate people to do that. And finally, some takeaways. First takeaway, if you are building a server-driven UI system, remember, this is meant to solve a specific problem, not all problems, all scalability problems you have. It's meant to solve like a specific set of problems. You can avoid headaches by thinking ahead and having a well-defined specification, some support libraries to help you, and a design system in place. Think ahead and mitigate possible problems with versioning, with the purpose of your library, how you communicate that to the people that are using it, and how extensible it's going to be. And finally, the last takeaway, remember that this is a multidisciplinary solution that involves engineers from Android, iOS, web, backend, and coordination and communication is key to build something that serves everyone until Kotlin multi-platform takes over. And that's it. Thank you very much, and I will be around if you have any questions later. So thank you.